Chapter 5 is intravenous medications. So we're going to be dealing with administering dosages intravenously, which is an IV. So we're essentially going to have two types of problems to solve. We're going to have to determine the IV infusion rate or the flow rate. So what this means is essentially how many drops per minute should the IV infuse, and we're also going to have to determine the length of time for infusion, which is how long the IV should run. So typically in most cases we have these modernized IV pumps that are computerized, but we should definitely still learn how to do these calculations by hand without having to rely on that IV pump. Different IV tubing sets can have different size openings, and these are going to administer different size drops of medications, and this is going to be indicated on the IV set with a number that's called the drop factor. So some examples of different drop factors are listed right here. We have 10 drops per milliliter, 15 drops per milliliter, 20 drops per milliliter, and 60 drops per milliliter. And just a reminder, the GTT is the abbreviation for drops. So what this means, if we have a drop factor of 10 drops per milliliter, it means that 10 drops will be administered, or rather 10 drops will administer 1 milliliter of fluid. And a drop factor of 60 drops per milliliter is going to mean that 60 drops will give off 1 milliliter of fluid. So the larger the number, the smaller the drops must be. So the drop factor is something that's going to be given to us, or we can find it on the IV set. So we just do not need to ever calculate that drop factor. So the formula we're going to be using here to solve both types of questions that we mentioned at the top of this page is going to be as follows. So this is essentially the main formula for this section. We have the drops per minute over on the left, and that is the IV infusion rate. So the IV infusion rate is going to equal the volume in milliliters times the drop factor, which is in drops per milliliter, divided by the total time in minutes. So notice that on the right side of this equation, if we multiplied the numerator, it'd be milliliter times drops per milliliter. So milliliters would cancel. We'd be left with drops per minutes, which equals the units for the infusion rate on the left. So just kind of a verification that the units end up working out. Okay, so I definitely know this little formula. We're going to be coming back to it a lot for the questions in this section. So starting with the first type of question, which we mentioned on the top of the last page, determining the IV infusion rates. So like I just mentioned, the IV infusion rate is measured in drops per minute, the GTT over minutes. And as we just saw in that formula, we can calculate this by multiplying the volume of the liquid in milliliters to be administered by the drop factor, and then divide that product by the length of time in minutes for the infusion. So it's going to be the volume in milliliters times the drop factor divided by the total amount of minutes for the infusion. So things we have to watch out for: we might have to convert the volume to milliliters, we might have to convert the time to minutes, and typically what we're going to be doing is round our answers to the nearest whole drop. Okay, so let's do a couple examples here. A physician orders 1,000 milliliters of D5W IV to infuse over 8 hours. So as a reminder, the D5W is 5% dextrose in water. We're given the drop factor of 15 drops per milliliter. We want to determine the IV infusion rate. Okay, so let's write down the formula from that previous page. So we have the IV infusion rate in drops per minute. That's going to equal the volume times the drop factor divided by the total time. And let's take a look at the given information here. We have the volume in milliliters. We have the time, which is in hours, so automatically we know we're going to have to convert that into minutes. And then we have the drop factor. In the proper units, we have 15 drops per milliliter. Okay, so it's pretty much plug and chug, plug these three numbers in, except first we have to convert 8 hours into minutes. So if we're going from hours to minutes, technically all we have to do here, it's just a unit conversion. We would just have to set up a proportion or use the dimensional analysis approach. All you have to do is multiply by 60. So 8 times 60 is going to be 480, which is 480 minutes, and that's what we're going to be using in our formula. Okay, so let's set this up here and plug in our numbers. So we have our infusion rate, drops per minute, equals 1,000 milliliters times 15 drops per milliliter divided by 480 minutes. We recognize the milliliters cancel, which they always should, or else the units are incorrect and we have to change them. And we end up getting 1,000 times 15, and then dividing that by 480. We end up getting a infusion rate of 31.25, which ends up rounding to a whole number. So recall that we said we're rounding it to the nearest whole number here. We round it to about 31 drops per minute, and that is our answer for the IV infusion rate for this one. Okay, so let's do another example here. We have an order for 500 milliliters Ringer's lactate IV to infuse over 6 hours, and we have the drop factor is 10 drops per milliliter. We want to determine the IV flow rate. So the flow rate is the same as the infusion rate, so I'm just going to write the same formula down. So we have the same formula as we did before, so let's take a look at the information that we have. We need 3 pieces of information. We have the volume in milliliters, which is what we need, correct units. We have the drop factor, 10 drops per milliliter, which is what we need. And we're given the total time of 6 hours. So once again, we have to convert that into minutes. We have to multiply that by 60. And multiplying that by 60, we get 360 minutes. So that's what we're going to be using in the formula, and we're going to plug everything in here. So the volume is 500 milliliters. And the drop factor is 10 drops per milliliter. And we divide that by the total time, which was in minutes. So that was 360 minutes. And multiplying in the numerator, we see that the milliliters cancels out. You don't have to always do that by hand and show that, but it always should. And then 500 times 10, we get 5,000. And lastly, dividing 5,000 by 360, we actually get a repeated decimal of 13.8 repeating. And we have to remember that we're rounding that to the nearest whole number, which is going to be 14. So the IV infusion rate, or the IV flow rate, is going to be 14 drops per minute. Okay, I'll do 2 more quick examples here. We have the physician orders 2 liters of D10W, so that's the 10% dextrose in water. So 2 liters of D10W IV over the next 12 hours. The drop factor is 20 drops per milliliter, and we want to know how many drops per minute should be infused. So once again, this is the same thing as the infusion rate. So let's write down the formula. So we need our volume. We have a volume of 2 liters, so we need to convert that into milliliters. 2 liters equals 2,000 milliliters. So hopefully we're comfortable with that conversion at this point. I'm just going to put that over here on the left side. That's the volume. Next, for the drop factor, we have the drop factor 20 drops per milliliter, so we're good with that. We don't need to change that. Next, we have time, which is our last one, just 12 hours. And 12 hours in minutes, we have to multiply that by 60. We get 720 minutes. So let's plug everything into this equation. So I'll just pause it and just fill out the whole thing up to the answer. And we end up getting a IV infusion rate, or the IV flow rate, of 56 drops per minute. So for this next example, it's set up a little bit differently. The physician orders 500 milliliters normal saline IV to run at 250 milliliters per hour, and the drop factor is 10 drops per milliliter, and we wanted to determine the IV infusion rate. Okay, so setting up the equation, then we'll talk about what we're given here. So we're given the volume, we're given the drop factor. For the total time though, we're given this rate, or this ratio of 250 milliliters for every hour. The easiest way to do this, there's a couple different ways to do it. The easiest way to do it is ignore the total volume of 500 milliliters. Okay, so we're going to ignore the total volume of 500 milliliters. We're going to use the ratio 250 milliliters for every hour. When we're using that, that means the volume is 250 milliliters, and the total time is 1 hour, which is 60 minutes. Okay, so we're going to use those values, ignoring the 500 milliliters. So let's plug in these three values now. So when we plug everything in, that's 250 times 10 divided by 60. We end up getting 41.6 repeating, which rounds to 42. So that is a IV infusion rate of 42 drops per minute. Okay, so for the next thing before we get into the last part of this section is intravenous piggyback medications. We can abbreviate this IVPB for intravenous piggyback. So what this is, it's a secondary medication that's linked with the primary IV line, and it's called a piggyback because it's usually going to be a small bag that's near the larger primary IV bag. And this is going to be a convenient way to administer a small amount of a second medication without having to start a whole entire second IV on the patient. And typically these piggybacks contain 50 to 100 milliliters and are given from a time span of 30 to 60 minutes. Okay, so let's do an example. The physician orders ampicillin, 250 milligrams IVPB, so the piggyback medication, and the piggyback label is going to read 250 milligrams and 100 milliliters normal saline, and we have to infuse for 30 minutes with a drop factor of 10 drops per milliliter. We want to determine the infusion rate. Okay, so let's write down the equation right away. Let's worry about the given values after we have the formula to see what we need. Okay, so we have our formula. So we need the volume in milliliters, the drop factor, and the total time. So drop factor, let's find that first. It's going to be one of the easiest. That's 10 drops per milliliter. And we have the time for the denominator of 30 minutes. That's already in minutes. We don't have to make a conversion at all. So the only other thing we need here is the volume in milliliters. So it's kind of obvious which number we're using because it's the only number that's in milliliters. It's going to be the 100 milliliters that we're using for our volume in the formula. So we're not using the 250 milligrams, that's the dry amount. The 100 milliliters is the volume that the 250 milligrams is contained in, so that's the one that we use. So all of these are in the correct units. We don't need to make any conversions. So let's plug everything in and calculate this. So plugging everything in, we have 100 milliliters times 10 drops per milliliter divided by 30 minutes. We end up getting 33.3 repeating. Rounding that to the nearest whole number is 33. So our infusion rate is 33 drops per minute. Okay, so we have Keflin 1 gram IVPB every 4 hours is ordered, infused in 60 minutes, and the piggyback label reads 1 gram in 50 cubic centimeters, 5% dextrose in water. The drop factor is 60 drops per milliliter, and we want to determine the piggyback flow rate. Okay, so we have our formula here. We have to figure out what to plug in. So the drop factor is 60 drops per milliliter. And the total time is going to be 60 minutes. Once again, this is in minutes. We don't have to make any sort of conversion, which is nice. And lastly, we just have to figure out the volume once again. So we have to be careful. The 1 gram is not a volume. The 50 cubic centimeters is the volume. And we have to remember that 50 cubic centimeters is the same as 50 milliliters. Okay, so once we have that, all we have to do is plug everything in and evaluate it. Okay, so we end up getting 50 milliliters times 60 drops per milliliter divided by 60 minutes. So this one's kind of nice because the 60s cancel and we're just left with 50. So we have a flow rate for the piggyback of 50 drops per minute. Okay, let's do one more like this before I move on to the last thing. So the order is for gentamicin, 50 milligrams IVPB, and the piggyback label reads 50 milligrams in 0.1 liters normal saline. We're going to infuse for 1 hour, and the drop factor is 15 drops per milliliter. We want to know how many drops per, that should say, minute should be infused. Okay, so we have our formula for our infusion rate or our flow rate, and let's take a look at what we need to plug in here. We have our drop factor as 15 drops per milliliter. We have the infusion rate of, or the infusion total time of 1 hour. So we know 1 hour is going to be 60 minutes, so I'm just going to write that in here, because we're going to need that in minutes and not hours. And lastly, for the total volume, the milligrams here, the 50 milligrams is not a volume, so that's not the number that we're using. We're using the 0.1 liters as our volume, but we need to convert this to milliliters. 0.1 liters, we would have to move the decimal over 3 to the right. That'll give us 100 milliliters. Okay, so plugging in our values, we have 100 milliliters, 60 minutes, and 15 drops per milliliter. So plugging everything in, and let's calculate this. So running this through, we get 100 times 15 divided by 60. That gives us an infusion rate of 25 drops per minute. Okay, so for the second type of question here, we can determine the length of time for an infusion. So we just determined the infusion rate. Now we can determine the time for an infusion. So this time we're going to be given the infusion rate, and we're going to calculate the time, and we're going to be using the same formula, but the work is actually just going to turn out to be a proportion. So before we actually get into an actual problem here, let's use this page to review time in general. So let's say we had 280 minutes. That's really not a great description for time. A better way to say 280 minutes would be 4 hours and 40 minutes because it's just easier for us to understand. If we want to change minutes, if we want to change minutes into hours and minutes, we're going to divide by 60, and the remainder is going to be the number of minutes. The quotient, or the answer, will be the number of hours. The remainder will be the number of minutes. So let's see an example here. Let's do 280 minutes. Convert 280 minutes into hours and minutes. We're going to divide 280 by 60. So when we're dividing this, we have to think how many times does 60 go into 280? Well, it goes in 4 times, and then we multiply 4 times 60, we get 240, and we subtract, and we get 40. We know that that is our remainder. That's where we stop because 60 is larger than 40. we probably at this point know that we could add a decimal in and bring down a 0. We do not do these for these questions. When we're converting, we're not going to deal with decimals at all. Once we get a remainder, we are done. So we get that 280 minutes equals 4 hours and 40 minutes. So also don't use the calculator to divide this. What we'd end up getting in the calculator is the decimal representation. We would get 4.6 repeating hours, which is technically correct, but it's not very helpful. Okay, so let's do one more example here before we get into the last couple examples for this section. We want to change 532 minutes into hours and minutes. So we're going to divide. We're going to do 532 divided by 60. So we have to think, how many times does 60 go into 532? It goes in 8 times. Then we multiply 8 times 60, we get 480. And we subtract, and we get 52. So 52 is smaller than 60, so we're done. And that means 532 minutes equals 8 hours and 52 minutes. Okay, so now let's actually get into the last couple examples here. So we have an order of 1200 milliliters Ringer's lactate IV to infuse at 50 drops per minute. The drop factor is 15 drops per milliliter, and how long should the IV infuse? So let's set up the same exact formula. And let's take a look at what we are given. So this time we're looking for the total time. We are looking for this down here, and we are given the infusion rate, and we're given the drop factor, and we're also given the volume here. So we have the infusion rate, we have the drop factor, and we have the volume. So let's plug everything in and see what we're left with. So we have, for the infusion rate on the left, we know it's 50 drops per minute. That means it's 50 drops for every 50 drops for every 1 minute. I just put milliliter down there by accident. 50 drops for every 1 minute. Even though it's not written in the problem, it means 1 minute. And for the volume, we have 1200 milliliters. For the drop factor, we have 15 drops per milliliter. And notice for total time here, instead of keeping it as total time, I'm just going to use an M for the variable that we're looking for. You could use an X if you want. So once we have this, you can recognize that it's just a proportion now. So we can simplify a little bit, and we can multiply the 1200 times the 15. So we get 50 over 1 equals 18,000 over M. And notice I just got rid of the units just because it's just a normal proportion now. And we're going to cross multiply here and solve for M. And we end up getting 50M equals 18,000. Divide both sides by 50. We get M equals 360 minutes. So remember what we just did on the previous page. We want to convert this into hours and minutes. So what we would do is we would divide this by 360, or divide the 360 minutes by 60. And we get an infusion time of 6 hours. Okay, so it didn't show all the work just because we've done this. We've done the proportion with cross multiplying, and we just did the dividing by 60. Okay, so let's do 2 more here. So we have an order of 500 milliliters, 5% dextrose in water, IV, to infuse at 60 drops per minute. The drop factor is 15 drops per milliliter. We want to know how long should the IV infuse for. So let's set up the formula. And we take a look at what we're given in the problem. We are given the volume in milliliters, so we don't need to convert anything. We're given the infusion rate of 60 drops per minute, and we are given the drop factor of 15 drops per milliliter. Okay, so it looks like we don't need to convert anything, so we can just set this up and plug everything in and solve for time, and I'm going to use m as the variable for time again. Okay, so for the infusion rate on the left, we have 60 drops for every 1 minute. And then on the right hand side in the numerator, we have the 500 milliliters times the 15 drops per milliliter. And the milliliters are going to cancel, and let's just multiply that numerator on the right, 500 times 15. And we get 7,500. And once again, I'm just dropping the units. So we cross multiply here, and we will end up getting 125. And we divide the 125 by 60 to get it into hours and minutes. And we end up getting 2 hours and 5 minutes. Okay, so let's do one more here. So the physician orders 1.5 liters dopamine IV to infuse at 35 drops per minute. Find the length of time for infusion if the drop factor is 20 drops per milliliter. Okay, so we have our formula here, and we have our volume of 1.5 liters. So converting this into milliliters, we have to move the decimal 3 to the right. That's going to be 1,500 milliliters. So there's our volume, and then we have the infusion rate of 35 drops per minute, and we have the drop factor of 20 drops per milliliter. Okay, so we're going to plug in these three values. We converted what we had to convert. Okay, on the left for the infusion rate, we have 35 drops for every 1 minute. On the right, we have the numerator that we can multiply where the milliliters will cancel. And then in the denominator, we have m for total time, which is what we're looking for. So let me just multiply 1,500 times 20. And we get 30,000, so I just drop the units. So 35 over 1 equals 30,000 over m. We are going to cross multiply and solve for m, and we're going to get 857.1 minutes when we cross multiply and solve that for m, and we're going to round that to 857 minutes. And now we need to divide by 60 to put this into hours and minutes. So let's just do this one by hand on the side here. Okay, so what I would say is how many times does 60 go into 85? So I'd put a 1 right here, and then multiply 1 times 60, subtract, we get 15, bring down the 7. Then we say how many times does 60 go into 157? It looks like it goes in 4 times. And then we multiply 4 times 60, and we get 120. Oops, that would have been 240, but it looks like up here should have been 25. There we go. 85 minus the 60 is 25. Bring down the 7, and then 60 goes into 257 4 times. We multiply that through. We get 240, subtract, and we get 17. 17 smaller than 60, so we know that we're done. So that means the total time is going to be 14 hours and 17 minutes for the total length of time for the infusion. Okay, so this whole section was essentially the same formula. We just would solve for either the infusion rate or the total time for the infusion. Okay, so that's it for chapter 5.